Hello, everyone. In today's episode, let's join English Discovery News to explore an extremely hot topic: the genetic revolution, playing God, the source code of life. For billions of years, life on Earth evolved through a slow, random process called natural selection. It was a game of chance. But that era ended in 2012 with the discovery of a technology called CRISPR-Cas9. Imagine if the book of life, your DNA, was no longer written in permanent ink, but in pencil. And imagine we just invented the eraser. We now have the ability to cut, paste, and rewrite the genetic code of any living thing: plants, animals, and even humans. This is the genetic revolution. It promises to cure all diseases, end world hunger, and perhaps even defeat death itself. But it also opens a Pandora's box. Are we ready to take control of our own evolution? Or are we children playing with a loaded gun, capable of creating monsters we cannot control? CRISPR, the molecular scissors. To understand the power, we must understand the tool. CRISPR is often described as molecular scissors. It is a cheap, precise, and easy-to-use tool that allows scientists to find a specific sequence of DNA inside a cell and cut it out. Before CRISPR, genetic engineering was like trying to edit a book by ripping out random pages. It was expensive and inaccurate. With CRISPR, it is like using the find and replace function in Microsoft Word. You can correct a single typo in a book of 3 billion letters. This technology has democratized biology. What used to cost millions of dollars and take years can now be done by a graduate student for a few $100s. The barrier to entry for playing God has collapsed. The end of disease. Let's start with the miracle. There are over 6,000 known genetic diseases, from cystic fibrosis to Huntington's. For history, these were death sentences. Now, they are just coding errors. We have already seen the first victories. Victoria Gray, a woman with sickle cell disease, was effectively cured after doctors used CRISPR to edit her bone marrow cells. This is just the beginning. Scientists are working on editing immune cells to hunt down cancer more effectively. They are trying to edit the genes of mosquitoes so they can no longer carry malaria, potentially saving millions of lives in Africa. In this vision of the future, hospitals are not places where you manage symptoms. They are software debugging centers for the human body. Designer babies. But if we can fix a disease, can we also fix a normal trait? This brings us to the most controversial topic: designer babies. If you can edit out a heart defect, why not edit in blue eyes? Why not increase height, muscle mass, or even intelligence? We are moving toward a world where children are not born, but designed. This creates a terrifying prospect of a genetic caste system. Imagine a society where the rich can afford to buy their children higher IQs, perfect vision, and immunity to cancer. The poor would remain natural, while the elite would become a genetically superior species. The inequality gap would no longer be just about money. It would be written into our biology. The movie Gattaca is fast becoming a documentary. The super soldier. Governments are not just interested in curing the sick, they are interested in building the strong. Intelligence agencies warn that dual-use biotechnology is a major national security threat. We know that genes control pain tolerance, muscle density, and the need for sleep. It is theoretically possible to edit a human to run for days without fatigue, to see in the dark, or to feel no fear. In 2020, then Director of National Intelligence John Ratcliffe warned that China has conducted human testing on members of the People's Liberation Army in hope of developing soldiers with biologically enhanced capabilities. We are entering the age of the enhanced warfighter. If one nation builds a super soldier, every other nation will feel forced to follow. The arms race of the future will be fought in the laboratory. The biohackers. Nuclear weapons are dangerous, but they are hard to build. You need uranium, centrifuges, and massive infrastructure. Biology is different. The knowledge is digital, and the equipment is cheap. This has given rise to the biohacker movement. These are amateurs experimenting with gene editing in their garages and community labs. Most are well-intentioned, trying to make glow-in-the-dark plants or brew new types of beer. But the risk of a lone wolf is real. What if a terrorist decides to synthesize a version of the smallpox virus, but edits it to be resistant to vaccines? A single person with a grudge against the world could theoretically engineer a pandemic that kills billions. Biology has an asymmetric threat profile. One person can cause global destruction. De-extinction. The power to edit life extends to the dead. Companies like Colossal Biosciences are currently working to bring back the woolly mammoth. By taking DNA from frozen mammoths found in the Arctic and splicing it with the DNA of an Asian elephant, they hope to birth a mammoth calf within this decade. They argue this could help restore the Arctic ecosystem and fight climate change. Others are looking at the dodo bird or the Tasmanian tiger. But is this conservation, or is it a vanity project? Reintroducing an extinct species into a modern ecosystem could have unforeseen consequences. We are reversing history, blurring the line between the past and the present. Just because we can bring them back, should we? The death of death. Ultimately, the final boss of genetic engineering is aging itself. For centuries, we accepted death as inevitable. But biologists now view aging not as a destiny, but as a technical problem. Aging is simply the accumulation of cellular damage and genetic errors over time. If we can use CRISPR to repair that damage and reset the epigenetic clock, can we stop aging? Silicon Valley billionaires like Jeff Bezos and Peter Thiel are pouring billions into longevity research. Experiments on mice have already succeeded in extending their lifespans significantly and reversing blindness. If humans can live to be 150 or 200 years old, it changes everything: retirement, population, marriage, and resources. We might be the last generation to accept death as natural. Conclusion: the genetic revolution is different from every revolution before it. Fire gave us the power to burn. Nuclear gave us the power to destroy. But genetics gives us the power to create. We are no longer just the passengers on the ship of evolution. We have seized the steering wheel. The potential for good is infinite. A world without cancer, without hunger, without suffering. But the potential for evil is equally vast. We are rewriting the operating system of 4 billion years of life. If we make a mistake in the code, there is no Control-Z to undo it. We are playing God, but we are still just human. Discussion. This topic forces us to define what it means to be human. Question of the day: should we ban gene editing on human embryos to protect our species, or is it our moral duty to use it to eliminate all genetic diseases, even if it risks creating designer babies? This is a clash between precaution and progress. Let me know your thoughts in the comments with the keyword ban or edit. I'm English Discovery News. Decode the world, question everything, and I'll see you in the next deep dive.